All right, guys, this is the lesson for Chapter 10, Section 6 on circles and arcs. Get the screen a little bit bigger there. This has a lot of definitions. I'm going to put it on you to go through the book and make sure you understand the definitions. But you should already know the difference between a diameter and a radius. We're going to be dealing with circles. So let me draw a circle here. Does not have to be perfect. A diameter obviously is all the way across. A radius is part of the way across. And a lot of times you will have these named consecutively around the circle. This would be circle P because the center is P, and AB is a diameter, PC or CP is a radius. But we also have these things called arcs. Okay? An arc is the distance around the outside of a circle. So it's a slightly different designation. You always want to use two letters if you have a minor arc. So BC with an arc on top of it is what's called a minor arc. A minor arc is less than half a circle or less than 180 degrees around. Get rid of that real quick. For some reason it's not letting me get rid of that. There we go. A major arc would be more than halfway around. So A, B, C has to be a major arc because you go from A all the way around to C, and a major arc is going to be more than 180 degrees. All right, the naming of arcs I don't think will be all that difficult. I'll leave that for you to review in your book if you need a little extra information, but it should be fairly self-explanatory from the book. But there was a brief lesson. But there's enough other stuff in this chapter that I want to move on in this section, excuse me. I want to move on to make sure we have enough time since we've got a 15-minute limit on these videos. Measuring an arc is the next thing, okay? The key component here, and this is something that if you're taking notes while doing these videos, I would say put a star on your notes and write down how to measure an arc. The measure of an arc is always going to be equal to the central angle that forms it. So if I have a circle, whoops, gotta switch to my writing tool. If I have a circle like that, and this arc right here is about 80 degrees, there's A, there's B, this is circle P, and that's an 80-degree arc, then arc AB, let's put the little arc over it, is going to be equal to 80 degrees also. So the central angle that forms an arc would give you the measure. Now, if there was another point on here, point C, what's the measure of arc ABC? Well, excuse me, what's the measure of arc ACB? Let's go around that way. Well, how many degrees does every circle have? 360. If it's got 80 in here, well, all you would have to do is 360 minus 80. 360 minus 80 would be 280 degrees. So the measure of the major arc, which goes with the minor arc AB, the remaining degrees would be 280 degrees. Now, there's also the arc addition postulate, which just states that you can add arcs. What is arc AB plus arc ACB? Well, 80 plus 280 is 360. Plus, you can also tell from the picture that it goes around all the way around the circle. All right, so let me erase that. We'll get to a problem like in the book to give you an example of what some of the homework will be. All right, almost got that. All right, so if you've got a problem like they do in the book where you've got a circle, And then in that circle, you have circle 0. So the center is 0. A's out here. D is there. C is there. Easier said than done with this stylus. And then B is here. So here's B, C, D, and A. And that's O in the middle. And it says, okay, what is the measure of each arc in circle 0? The first one is BC. Well, the measurements are 32 in this central angle. That's the only one we know. But, and I drew it wrong, we also know that CA is a diameter. Okay, so there's A right here. If CA is a diameter, doesn't that mean that I'm going to have 180 degrees around CA either way? So I've got 32 here. I would do 180 minus 32, which would be 148. So this is 148. And then you're also shown in the book that you have an arc of 58 degrees between C and D. All these have degrees, but I can't do the degree sign very well. My writing is messy enough without using the stylus. Well, if each arc is formed from the central angle, doesn't this have to be 50? And then doesn't this have to be 130? You add all those up, you should get 360 degrees of arcs. So AB is 148. Arc ABC has to be 180 because it's a semicircle. Arc BD has to be the 50 plus the 32. Remember, the arcs are formed by the central angles. So this arc over here is 130 and this is 148. Central angles go with the arcs on the outside. Again, I think you'll find that this particular section is pretty easy if you remember much of the geometry that you learned in middle school. Arcs are a little bit different, and we'll learn a few new rules in geometry, however, that you have not had previously. All right, so you can also find the circumference. You'll need to know that the circumference of a circle, it's like perimeter of a circle. So it's either pi d or 2 pi r. Okay, and it just depends on what you're given. If you're given a radius, use 2 pi r. If you're given a diameter, use pi d. It's the same thing because 2r is the same thing as your diameter d. All right, and so we get to the final portion of arc lengths that are portions of it. Let's say this. If I've got a circle, and that circle has an arc here of 90 degrees. I intentionally made this one 90 degrees. And I knew that the circumference of this particular circle was 36 pi. If you're ever told to leave an answer in terms of pi, just leave pi in your answer. On Math Excel, it'll give you an option for it. But it asks you, in this case, what is the arc length of AB? That's supposed to be a B right there. Well, the overall circle 0 circumference is 36 pi, but AB is 90 out of 360 degrees. Agreed? Also known as 1/4 of the circle. So what you're going to do to find arc lengths is you're going to set up the arc over 360 degrees and then multiply it by the circumference that you're given, in this case 36 pi. You're going to notice that you could simplify this to 1/4, and 1/4 of 36 is just 9, or 36 divided by 4 is 9 pi. And so the arc length of arc AB would be 9 pi. The book also has an example. It has one of those theorem boxes, and it's going to give you some example problems, but I hope that that brief tutorial will get you started. If you have any questions, let me know. We're already at about 10 or 11 minutes, so I'll stop here. This one I have planned to be due on Friday, but give me some feedback. Let me know how Math Excel is going, and if you're figuring it out, don't be afraid to ask for tutoring Monday, Tuesday, or Thursday in the afternoons. Honestly, even other days perhaps, but you need to send me a text and see if I'm available. Hope things are going well. Talk to you again